Hey guys, Azamat here, and take a look at this. Pretty cool, huh? Well, actually, that's a battery. It's the same thing that charges and makes almost all of our inventions work. Starting with television remotes and ending with gigantic mass production factories. One of its kind is located in Taldykorgan, Kazakhstan, and is controlled by Kaynar AKB. This ginormous complex started its construction in 1970 and made its first ever battery in January 1975. The company Kaynar AKB is considered to be one of the ground layers of our national domestic manufacture. Being a part of Samruk Kazna Holding and a member of the International Union of Battery Manufacturers Interbat, Kaynar AKB holds an incredibly big role in the economy of our nation. This factory in particular is fully self-sustaining, which means that all of its components for the lead-acid battery manufacture are made directly inside its battery plants. Now, let's talk about ecology, in particular about carbon dioxide. We all know why we hate carbon dioxide this much. It's because it causes a process called global warming. And it's not a joke, it's 100% real. According to the statistics, since the start of the 20th century, our Earth got warmer by almost 1 degree Celsius, which is approximately 1.4 degrees Fahrenheit. It may look quite small on a scale, but actually, because of this 1 degree increase in global temperature, almost 95% of the oldest and thickest ice in the Arctic is already gone, leaving cute polar bears without a home and the sea level at a dangerous high index. Additionally, a light increase in the concentration of CO2 in the atmosphere can cause significant health issues among humans and also among some species of bees and mammals. We need to find a fast and efficient way to solve this problem now, or else our humanity will face its greatest challenge yet. That's why I want to introduce you to the idea of carbon dioxide lead-acid batteries. The idea of a carbon dioxide battery first was developed by the scientists of Massachusetts Institute of Technology. Especially, this idea gained huge traction after the work of Sahag Woskin and Alan Hutton, who is a chemical engineer professor, while Sahag Woskin is a postdoctoral researcher. Together, they made some groundbreaking research concerning the carbon dioxide batteries. This process is actually the same working principle behind a car battery. It has the same large set of electrochemical cells that are composed of electrodes, separators, and a counter-electrode. In this case in particular, the electrodes are sponge lead and lead dioxide, while the counter-electrode is sulfuric acid. The main carbon dioxide attracting element in this process is a thing called polyanthraquinone, which is an organic component directly derived from aromatic components like benzene and naphthalene. This class of quinones are especially popular because of their large redox potentials, which basically means that they're easily able to give away and to attract electrons from other elements. By separating cells inside the battery and then coating the outside electrodes with polyanthraquinones that are also covered with carbon nanotubes to enlarge the area of interaction with carbon dioxide, we can potentially trap any molecules of CO2 that are consisted in the air without a limit of the concentration level. This means that during the charge of the battery, the polyanthraquinones gain electrons from the lead electrodes. By gaining these electrons, they can then attract CO2 molecules to themselves and then hold them together for a long period of time. After the discharge, the polyanthraquinones push the CO2 molecules away because they lose their electrons. These CO2 molecules combine with each other to create a large stream of pure carbon dioxide. Then we can store this stream inside a given volume, use it for carbonating drinks, for example, or to bury it underground, or to give it to greenhouse plants so that they could grow larger. The main advantage of this technology compared to other carbon capture innovations is that this technology uses normal room and car temperatures and pressure without the need of additional facilities. That's why this technology is so cheap and almost ultimate, because it can be used at any time, at any car, and super easy to produce. In a time of crisis, we have to make decisions now. If you're not able to make necessary moves, then the point of no return may come quicker than we might expect. We only have one mother planet, which is our Earth, and it needs very special and delicate care. Which is why I think that if we use this new idea of carbon dioxide batteries, then maybe, only maybe, the humanity will be able to face another 1000 years in the future together with its green planet.